In this video, we are going to talk about how do we construct a confidence interval when we are trying to estimate a population proportion. We'll also talk about how do we interpret that confidence interval once we have got it, and what are some of the other calculations that we need to do in order to really come up with a confidence interval, right? So a beta percent confidence interval, right? A beta percent confidence interval for a population proportion, it will look something like this. It's going to be P1 is less than P is less than P2. So here you should imagine that these values P1 and P2, those are actual numbers, right? So there is some number here that you're going to generate somehow, and a number here that you'll generate somehow. And so we are going to be saying that we think that the value P lies between these two numbers. Actually, I should be a little bit more careful. What we're really saying is we think that these two numbers, this interval, actually does contain the value P. Right? So this is how we interpret this. We interpret this by saying we are beta percent confident that the interval from P1 to P2 actually does contain the true population proportion P. So when you think through this, you should imagine that population proportion, it is what it is. You should imagine it being a fixed value. So we're never going to say this is that P is between P1 and P2 beta percent of the time. The thing that's changing here is the confidence intervals. The confidence intervals are going to be built all the way completely off of the samples. And so depending on what sample we get, the confidence interval it generates might be different, but the proportion of the entire population that believes something, that's going to be kind of consistent. All right. So to build a confidence interval, to do some of these calculations, we need to dust off some old terminology that we've had before, right? So we have, if we recall, a critical value. A critical value is a value that separates values likely to occur from values that are not likely to occur. Right? So that was a critical value. It separates values likely to occur from those that are not likely to occur. And we talked about, specifically, we talked about a critical z-value is a z-value. This is a z-value with an area of alpha over 2 to the right of the value. Eventually, in this chapter, we'll talk about critical t-values. This is a different distribution. We'll talk about critical chi-squared values. This is a different distribution. So we'll look at some other distributions other than just the z distribution. But the critical values are defined in really very similar ways, right? This is a t-value with an area of alpha over 2 to the right. So if we wanted to use StatDisk to find critical z-values, then we can select analysis, probability distributions, and then normal distribution. That's to find a critical z-value. If we were trying to find a critical t-value, we would choose t-distribution. If we were trying to find a critical chi-squared value, we would choose chi-squared distribution. And then for the normal distribution, we input the area to the left. Right? So that is the value 1 minus alpha over 2. And the z-value then that is output, that is the critical value. That is the z-value that has an area of alpha over 2 to its right. Now, it might seem strange that we did 1 minus alpha over 2 here, but here is the idea. We have a normal distribution when we're trying to find a critical z-value. We have this normal distribution. We have here in the middle, that area is 1 minus alpha. So between these two tails, we have an area of half of alpha. Well, those two tails combine to give us alpha. And so in just one of those tails, so let's say this tail, we have alpha over 2. And so all of this area, the area to So all of that area to the left of this value right here is 1 minus alpha over 2. All right, so let's look at an example where we're going to go through StatDisk and we're going to find some of these things. All right, we are asked to calculate a 95% confidence interval. What is the critical value of z sub alpha over 2? So first we need to identify what is the value of alpha. So if we're doing a 95% confidence interval, 95% is the confidence level. Remember, our confidence level is 1 minus alpha, so we have 1 minus alpha is 0.95. And so we could say alpha is 0.05. This is exactly equivalent to saying, like, how far away from 100% are we? We're 5% away from 100%, so that is the value of alpha. That's the area that's in the tails up in that distribution above. So if that's the value of alpha, we're finding z sub alpha over 2. So to find alpha over 2, we're going to take 0.05 and we are dividing it by 2. 0.05 divided by 2 is 0.025. And if we want to find what is the z value that has this as an area to its right, StatDisk asks us to input an area to the left. And so 1 minus 0.025, which is 0.975. That is the area to the left of the value that we're looking for. So let's go to StatDisk. I'm going to enter in analysis, probability distributions. We're dealing with a normal distribution. We're trying to find a z value. We are given, we know the area from the left. The area to the left is 0.975. So we plug that in and then we evaluate. This z value over here, that is the critical value. So that's how we calculated it using StatDisk. If we rounded to the third decimal point, we have 1 point. So in that fourth decimal point, we have a 9. So that's going to cause the 9 in front of it to round up to a 10. So we carry that 1. So we get 1.960 as that z value. That is the critical value here. 1.960. The next question is really similar, only this time we're going to be dealing with a 99% confidence interval. So in this case, our value of alpha is 0.01, and so alpha over 2 is 0.005. And so then if we take 1 minus that, 1 minus 0.005, we have 0.995 is the area to the left of the value we want. So this is not the critical value. That's the area to the left of the critical value. So I'm going to go back to StatDisk. I'm going to choose 0.995. That's the area to the left of the value that we want. And when we do that, we get a z value of 2.5758. We're going to round to the third place, and so that will become 2.576. So 2.576. So those are critical values. If we wanted to know what is the value down here on the left-hand side, because this is a normal distribution, because it has symmetry, that value on the left-hand side would just be the negatives of those values that we found there. But the value we're looking for here right now is just the positive value here. Now, we talked previously about the margin of error. We talked about that in the last video. So that is the maximum error or maximum likely difference between the population proportion and the observed sample proportion, right? And so we can find that using this formula right here. So the margin of error is z with a subscript of alpha over 2. So that's a critical z value that has an area of alpha over 2 to its right. Then we're going to take the square root of p hat times q hat over n. So the value p hat, that is our sample proportion. Q hat, that value is 1 minus p hat, the complement of our sample proportion, and that value of n is our sample size. So once we have that margin of error, the way we construct this confidence interval is using this. We're going to take p hat, the proportion from our sample, and to that we are going to both add and subtract the margin of error that we calculate in this way. All right, so that seems like a lot of stuff. We will talk more about that in the next video, but here's a little bit of a peek ahead. We're going to use StatDisk, and it's going to do a lot of the hard work for us, which is nice. All right, I'll talk to you guys later.